Duncan Quincy, thanks so much for joining me today to talk about this very interesting topic. I know you have some big research coming up here in the next year. I want to hear all about that as well. Can you give me a little brief background, though, on your area of expertise?
Yeah, sure. So I'm a glaciologist. I work at the University of Leeds in the UK, and I'm mostly interested in how high mountain areas of the world are responding to climate change. I'm specifically interested in how the glaciers are evolving, how long they're likely to be around as a water resource for the people who live downstream and depend on them, and really interested in the very high elevation processes that occur within the snow and ice, at around 6,000, 7,000 meters above sea level.
Okay. Well, that all pinpoints what we're going to talk about today. We're talking about Mount Everest, and I spoke to somebody who did an expedition this past year, and he didn't go all the way to the summit, but he did go to base camp, and he talked a lot. I work with him. He talked a lot about the things he saw and what surprised him. Can you give me a little brief overview, though, for some people who have no idea anything about Mount Everest? What some basics here? How tall it is, what the climate's like, what we're looking at here as far as extremes.
Yeah, sure. So the altitude of Mount Everest is 8,848 meters above sea level. A base camp where your colleague has been to, then you're talking around 5,300 meters above sea level. If you're looking up at the peaks, then you tend to be looking at nice, clean ice, snowy mountains, looks absolutely beautiful. And within the valleys, then you've got these glaciers which cut down, and they've eroded their way through the landscape. So they sit very much in the valley bottoms. The ice might be 100, 200, even 300 meters thick in places. And on top of that ice, then you tend to have a lot of debris cover, which has, effectively fallen off the mountain sides as the glaciers cut its way through. So it's fed onto the glacier surface by rock avalanche. And therefore, you're looking at quite a dirty kind of rubble-fed landscape. It's not necessarily the beautiful, clean ice landscape that you might associate with some other regions of the world, for example. It's a very hostile environment when you're up there. Temperatures at night, even in the pre-monsoon season, when most people are visiting that area, they might dip to about minus 10 degrees Celsius, that is, of course, below zero. Yeah, pretty cold at night, but then during the day, you can have really cloud-free weather, which makes it very pleasant to be there at that time of year. If you're there in the monsoon, then, as the name suggests, it's really very heavy rainfall for large parts of the daytime, and that's in the period, let's say, June through to September. And then through November into March, that's your winter time. So that's when it's getting extremely cold. And you probably don't want to be there in that time of year. There's some people stay there to monitor weather stations and that sort of thing, but largely at that sort of elevation, it's free of people around that winter period.
So when people are trying to reach the summit, there's actually a really small window of time, right, where it's safe?
Absolutely, yeah. So there's two main weather windows, just before the monsoon comes in and once after the monsoon has departed. So I think the slightly longer season, more reliable season is the pre-monsoon. So that's around May time. That's when most people will be making their way up there around April and climbing into May, that sort of time. And then again in November into early December, you might expect some more summits then. And then during those periods, I mean, you're really looking for a period where there's prediction of quite stable weather for a good few days so that people who are camped high can make that final push up to the very top. But it is actually quite a short weather window, which is why then you see these pictures more so recently of these long queues for people trying to reach the peak.
Yeah, it's a little deceiving. It makes you think that there's just constantly people up there. So I know that people started attempting to reach the summit like 100 years ago. So back in like the 1920s. I'm curious how the weather and climate has changed since then. What's your knowledge on the changing climate over the past 100 years when people have been attempting this?
Yeah, sure. I mean, I think we know now with quite some certainty that the last 100 years have been the warmest and the fastest warming for the last 2,000 years. So we are in a period of very fast warming, and we're currently seeing a temperature rise of about a third of a degree every decade For the last 4 decades, it's been something of that sort of order. The rain, on the other hand, or the precipitation, mostly snow actually at that elevation, that's been largely stable for the last 4 decades. So we are seeing quite a rapid rise in temperatures, and which is forecast, of course, to go on into future decades. Precipitation is a little bit more difficult to predict, but has been largely stable. But the overall impact then is that we're seeing quite a lot of glacier ice loss in this region, at accelerating rates as well, as you would expect to be hand in hand with the accelerating temperature increases.
Yeah, I think the initial reaction, people would be like, okay, so warmer weather, easier to climb Everest. Is it the opposite though? Are conditions actually getting much worse and more dangerous?
Yeah, in many ways, it does make it a lot more dangerous. I mean, for a start, the weather is much more unpredictable. And of course, I don't need to tell you, but we're seeing more extremes all of the time, less predictability. So those weather windows that we're talking about, it becomes very difficult for people to be able to predict them and to be able to rely on them. So there's the unpredictability element, but also as you warm these mountain environments, then you increase the instabilities. So with a frozen landscape, the ice is effectively gluing everything together. As soon as you warm that up and you introduce a layer of water in there, then things become a lot more unstable. So we see more rock falls, we see more avalanches, and we see previously stable glaciers starting to disintegrate. And that trek through the icefall, for example, where there's huge seracs, there's huge blocks of ice, and which are, you could say, poised to fall. We can expect to see that happening a lot more regularly as that environment warms up, for sure.
How do you get weather observations on Mount Everest? Is it people's notes? Like it's got to be such an inhospitable environment. It's got to be hard to measure anything up there.
It's pretty hard, yeah. But thanks to the National Geographic expedition of a few years ago, we now have a line of weather stations, which go up to about 8,100 meters. So there's several that are up there above the Khumbu Icefall. And until recently, they'd been telemetry and data out, so we could have real-time observations of what the weather was. So previous to that, I think that expedition was maybe 2019, 2020, something like that. Before that, then really we had a dearth of high elevation weather observations. So they've been really, really enlightening for this specific region. What I would say is that further afield, we don't have that luxury. Of course, this is Mount Everest, and of course, it attracts that sort of major investment and major expedition to have these weather stations put in position, and we don't have them elsewhere. But in this particular location, we are actually quite fortunate now to have some reasonable weather observations.
Okay. And aren't you working on a project this coming year that's going to help with that?
For sure, yeah. So we've got an expedition going out in April, May of this year, and we're interested in what's happening on the surface of the glacier at that sort of elevation. So the surface at about 6,000 to 7,000 meter up there is not actually glacier ice at that point. Well, it's in this transitionary phase that we call firn, and that's where the snow has been repeatedly laid on top of the previous year's snow and the previous year's snow. It's gradually being compressed. So it's not snow and it's not glacier ice. It's kind of this intermediate phase. And what we think is that as the meltwater at that sort of elevation infiltrates into that transitionary firn, then it releases quite a lot of latent heat and it warms up that firn and actually begins to create a glacier which is much warmer than the surrounding atmospheric temperatures. And this is something which is only recently starting to be realized in different glaciarized regions of the world. We have almost no observations of this at very high elevation, which is what we plan to do here. So these should be the first sort of observations that tell us about the preconditioning factors for glaciers within this region. And so hand in hand with that, we'll of course be putting up our own weather station data, because that will tell us about the incoming and outgoing energy sources. It will tell us about when there are melt events, and therefore we can then link those melt events that we see within the weather station data to what we see within the boreholes that we're going to drill into the firn at that sort of height.
Have you been before?
I've been to the Everest region many times. I've been up to base camp probably maybe 8, 9, 10 times now, but never beyond. So this is my first time going beyond Everest Base Camp through the Khumbu Icefall and into the Western Cwm. So I'm pretty excited about that. A little bit nervous, I have to admit, but yeah, I mean, once in a lifetime opportunity for a scientist. Of course, the climbers, this is what they do. But for scientists like me, generally tend to like to keep my feet on the ground rather than be hanging from a rock face or anything like that. So this will be a challenge. It'll be a challenge for me, and it'll be a challenge for our team. But we're hugely excited. Like, this is going to be an epic trip, and if we can get any observations from up there, then we'll be chuffed to bits.
I assume that you have a pretty good plan of attack when it comes to like a team. Are you bringing a lot of, I know there's like porters and the Sherpas, and you're carrying weather equipment, right? So what's the support team look like?
Yeah, so we work very closely with the Nepali logistics organization, Himalayan Research Expeditions. So they're used to doing this sort of work, although even for them, I guess this will probably be a push in terms of the elevations. So we'll have a whole support team. We'll have many porters which are carrying the equipment through to those elevations. Probably, I would imagine, double figures in terms of the number of porters that we'll have. We'll have a couple of very experienced guides to be able to take us through that zone and to be able to stay with us up there. And then we'll have a cook and the cook's team, so that we're not coming back from a day in the field and having to deal with our own meal preparations and that sort of thing. So yeah, it's a big team effort all around.
So why is it important to have this information? Why do we need to know about the climate of Everest?
This is a region that is very much dependent on natural resources for sustainable development. So as you go down from the glaciers, or as you walk up to the glaciers, you pass through many villages who are all using the water in some way, shape, or form that comes from these glaciers, that comes also just more generally from the precipitation that then feeds into groundwater and then brings the water through groundwater springs. So they're using it for hydropower, and they're using it for sanitation, for irrigation of the fields. So any changes to this supply in whatever shape or form, that's going to impact on food security, for example, but also energy production, just basic living needs for the people of this region. And that's the same in Everest as it is right across the whole of high mountain Asia. So very, very strong connection between the people and the natural resources that these glaciers and the climate ultimately is providing, as well as it having, huge cultural and spiritual value. The mountains are extremely important to the people of this region, often from a religious point of view. And so when they're seeing year in, year out, these environments changing, then it has big practical implications, but it also has big spiritual implications as well.
I know there's been a lot of discussion too about how the area is treated by people who are climbing it, as far as leaving trash or themselves when they die. So I'm curious, when you've been up there, what you've seen as far as pollution and litter. And then also, I'm curious about, I read an article about how warming temperatures are unearthing bodies that were never seen before because so many people have died in this attempt.
Yeah, I mean, when I've been there, there's been evidence of rubbish being stored within areas. I mean, this is inevitable given the footfall that goes through this part of Nepal every year, and there's been big efforts in recent years to clean a lot of that up. So it's still a very beautiful environment. And I would encourage anybody who's interested to go and enjoy it while we can. It really is an amazing sight. Um, there is some degradation. There is litter about the place in places, but as I say, there's a large effort at the moment to clean this up. And the Sagarmatha Pollution Control Corporation (SPCC) are doing a lot of work in this area. They've been tasked with bringing down a lot of the rubbish from above Everest Base Camp. So there has perhaps been some expeditions who have left some of their equipment behind because of no more use for it. Some equipment maybe discarded, that sort of thing. So SPCC has been bringing down tens of kilometers worth of rubbish within the last few years. And now they're moving to a drone-based system where this can be done semi-automated. So real hope there that we can clean this mountain up quite quickly. In terms of people and bodies melting out, this is thankfully not something which I've come across up to this point. I can imagine that there are bodies within the glacial ice, and it will take tens, probably hundreds of years for them to be transported through that system. The way the glacier moves is that if those bodies are incorporated within the glacier at high elevation, then they will be taken down almost on a semi-vertical trajectory into the glacier to start with, and then below the equilibrium line, that's when it will start to re-emerge towards the surface, because the glacier kind of moves in arcuate layers. So if you get stored in the glacier at the very top, you will get taken all the way through the glacial system and you will re-emerge down at the very terminus. So that would take hundreds of years for that to occur. So it largely depends on where bodies have been incorporated into the glacial system as to when they might melt out. But this is something that we're seeing actually in many glaciers across the world now. A lot of things emerging, aeroplanes in some instances that have crashed and been taken within the glacial system and re-emerging. Old climbing equipment is quite common. And this is something we'll see more and more of as the glaciers melt down and a lot of that englacial material is revealed.
I mean, it's so sad, but at the same time, it's so fascinating because all these old mysteries are being solved. Like wasn't a boot recently discovered from the Mallory Irvine mission? And we're talking 100 years ago, and now all of a sudden, these perfectly preserved things are being discovered.
Yeah, I think there's a lot of secrets that are wrapped up within these glaciers. They've been around a long time, and they've seen a lot of tragedy. They've seen a lot of attempts with people enjoying themselves and challenging themselves within these sorts of environments. So periodically, you do get these big news stories, don't you, where something interesting has appeared at the foot of the glacier, and you can link it back to exactly who it belonged to and what they were doing at the time. So it's fascinating. It's, of course, there is a tragic element to it sometimes. But a lot of the materials are just interesting from that sake.
So the work that you're doing, is it just looking at the future, or does any of it look to the past? Are you trying to uncover any sort of old climate data?
We are looking back into the past as well. And we're trying to understand then how important this process of the meltwater infiltrating into the snow and the ice at very high elevation, how important that's been for the glacier behavior over the last 40 or 50 years. The sort of time period that we can expect to get decent satellite coverage, for example, imagery of the glaciers, and that we have some form of reliable weather station data. So once we establish with our numerical models how it's behaving now, then we'll be able to force it with some of those historical climate data. And we'll be able to see then how important this process is in comparison to some others that may be taking place at those sorts of elevations too.
Hmm. I asked my colleague Scott if because this was his first time to Everest, but he would love to go back and do the summit one day. I asked him if he had any questions for you, and he had real concerns about the future. And he said, how much longer will we be able to do this? How much longer are people going to be allowed to do this?
I think we'll be able to do it for a long time, but I think that it will change very rapidly the experience that an individual has depending on when they go. So I think the landscape that Scott has been able to enjoy until, well, recently is one which is finite. So each year when I go back, I'll tend to look down on the Khumbu Glacier from the lateral moraine. So the moraine's the sediment which is piled up on the sides of the glaciers. And you get to the top of that moraine and you look down now on a glacier, and that glacier used to sit at the crest of that moraine that you're standing at. And it gets lower and lower and lower. In places, it's probably 100 meters below the surface where you're standing, which is quite incredible. And you look at it and there's more and more meltwater which is ponded on the surface. And so it's going to become increasingly difficult for people like Scott then to navigate their way across that sort of terrain, because you have to get down from those moraines onto the glacier surface. Some people who want to trek around the passes, they actually have to cross the glaciers as they go. And so it becomes increasingly difficult to navigate your way through the surface ponds. And in some places, it's almost not possible now for you to be able to do that. Certainly not very safely anyway. And so I think it's going to be a very changing landscape. Ultimately, then, the people who are going to Everest Base Camp, I think it's probably okay. You largely go on paths which aren't directly affected by the glaciers. But then for people who want to go beyond that and are actually having to climb through the glacial mass itself, through the ice fall, it's going to become increasingly fraught with danger, I think. And so will there come a point where actually it becomes impassable? Possibly. Our model data show that at some point that lower part of the glacier is actually going to detach from the upper part of the glacier. So it will just be like a stagnant block of ice sitting down at the bottom. And then the top part of the glacier will be avalanching onto that lower part. They won't actually be connected anymore physically. So actually trying to navigate your way through that area where there's ice peeling off and avalanching down, maybe there will become a point where they say enough is enough. You can't actually go that way anymore and you have to radically change the route up Mount Everest. That is quite possible.
Wow. Yeah. Sounds dangerous. Wow. Duncan, is there anything else you want to add about this or your research?
No, I think I would just emphasize that the reason we do this really is to be able to get a better understanding of how these sorts of changes that we're seeing, that you're looking at, I'm looking at from a different point of view, are really impacting the environment and how that impacts then on the people. Because ultimately that's why we care. That's the most important thing for the people of this region, is to have a better understanding of how their water supply is going to change over the next 100 years, something like this. Because at the moment there's high uncertainty in that. I think it's really important that we continue to do this sort of research and that it attracts funding to be able to do it, so that we can make those projections with a bit more certainty and people can live their lives with a bit more certainty, knowing what's going to be coming in 10 years from now, that sort of thing.
How does I'm always curious about kind of the intersect between physical science and social science. And we do it with weather. We talk about hurricanes here in the US and communities that they're impacted. How do you gain that knowledge of the people of Nepal and what their needs are and how this affects their lives? Are you working with people who study them or the communities themselves?
Yeah, a bit of both. So we tend to take a fairly interdisciplinary approach to the work that we do. So we do often work with social scientists and anthropologists, who are people who are looking at the communities, working with them, or embedded within them. In an ideal scenario, we also have very close partnerships with academics within Kathmandu University, Tribhuvan University, and ISIMOD. They're all based in Kathmandu, and they're all very much focused on the people of the region, the environments of the region. And so I think that's the best way that, as academics from the UK or from the US, we work also with people from the US, that's the best way that we can really get a good understanding of what the people of the region are concerned about, what they don't know, what they do know, what we all don't know, what we all do know. I think it's working hand in hand with them. So it's partnerships with other academics from the region who then give us the links into the organisations that are working with communities on the ground, and we can feed our findings into them so that then they can make better decisions going forward.
Can we catch back up with you this summer and see what's come of it?
Yeah, that'd be fantastic. I'd enjoy that.
Wonderful. Duncan, thank you so much. And I can't wait to see everything that unfolds.
Thanks a lot. Cheers.